Foundation course, page 134 to 135. We're looking at writing formally using letters and symbols. Well, you've been used to X's all your mathematical life, X's and Y's and A's and B's, and that's what we're looking at here. But we're going to take little storylines and convert them into little formulae. And here we go, question 6, starting with grade D. It says write an expression for each of these statements. So 6a says 4 times the number X. If I'm starting with X, then 4 times X will be 4X. Next one, 5 times the number Z plus 6 times the number X. 5 times the number Z will be 5Z, which means 5 times Z, plus 6 times the number X. That's the second one. Well, the third one. The sum of 2 times the number and double number Y. Read it again, I think I missed something out. The sum of 2 times the number X, so 2X, and double the number Y. The sum of 2 times X and double the Y. 2 times and double means multiply by 2 anyway. And it says the sum of, so we add. Next one, the product of the numbers X, Y and Z. Product means multiply, so we go X, Y, Z. By the way, the background is a beautiful field in Mallorca somewhere. These are 2 little ponies taken from a distance. I had to zoom in a little bit, so that's what that's about. Next one, the sum of 7 times the number, so 7 times the number X it says, and double the number Y, that's 2Y, and it says the sum of, therefore we add. So, bit of revision here. That means sum, add, and here we have the word product, which means you multiply, and then you get the results. You multiply and get the results. You've produced the products there. Back to black. Might have to use yellow down here so it stands out. Half the number Y, okay, so it'll be Y over 2, subtracted from 6 times the number X. So 6 times the number X is 6X, and then I'm going to subtract Y over 2, or half a Y, from that. Let me read it again. Half the number Y subtracted from 6 times the number X, and that's quite complicated, isn't it? No wonder it's grade D. Number 7, going to yellow. Think of a number, add 3, and of course I'm given the letter X to be the number, so think of a number, X, then add 3. Done it. B, think of a number, double it. Think of a number, double it, multiply by 2, C. Think of a number, subtract 5. Think of a number, subtract 5. Now we're on the pony proper. D, think of a number, okay, X, multiply by 3, that's 3 lots of X, add 2. There we go. Think of a number, X, add 1, multiply by 2. Now, this is badly worded. It should say multiply the result by 2. If you merely multiply the 2 at the end, all you're getting is multiplying 1 times 2, and the X doesn't get it. So that's wrong. It's actually going to be think of a number, add 1, and then what you get, you multiply by 2. So you've got to have a bracket there. Question 8. The hardest thing about question 8 is reading it all out. The rule for finding out how far away thunderstorms are is count the number of seconds between the lightning and the thunder, divide the answer by 5, and the answer gives the distance in miles. Write a formula for this rule. S stands for the number of seconds, and D stands for the distance in miles. So I've got a D and an S. Let me just read it. The rule for finding out how far away, the distance that is, thunderstorms is count the number of seconds, yes, between the lightning and the thunder, divide the answer by 5, so it's S divided by 5, and that will give you the distance. So D equals S over 5. That is me putting that little bit of description into math speak, into simple formula. It's an equation, in fact, what we've got. Here's the next one. You find out, this is question 9, again the hardest thing is reading it. You can find out how many amps an electrical appliance will use by this rule. The number of amps equals the number of watts divided by 240. So if I write it in English first, amps equals watts divided by 240. And incidentally, that 240 is the voltage in the UK. Write a formula for this rule. Well, I've got the words, let's change it to formulas. Use A to stand for the number of amps, so A, got you, equals watts, I'm told to do W, and 240 is 240. I can give you the proper physics formula for that, I won't do that, so let's keep it in the context of maths then. I think that's about, let's do one of these then. Question 13. It says here, write down a formula for the total cost, and that's T of this. So let's just turn over, I might need a bit more space. Let's go back to black for the sky. So total cost, so T equals, it says X lollies at 70 pence and Y lollies at 80 pence each. Right, so I've got X lollies at 70 pence each, so it'll be 70 times X, and that's plus Y lollies at 80 pence each, so it'll be 80 lots of Y. So let's look at it. 70 times X. If I buy 2 of this style of lolly here, I'll be 70 times 2. Alright, so 70 times however many this style of lolly is, plus 80 times whatever this type of lolly is. Add it all up, it'll give me a total cost in pence. Excuse me. C, right, the total cost of cakes now. Total cost of C cakes at 90p, so it'll be 90 lots of whatever that kind of cake is. And, well, that's plus. B biscuits at 20 pence each, so it'll be 20 lots of B. Please note, don't call it 90p and 20p, it gets very confusing. It's 90 times C, 90 pence times whatever number of cakes is that you've chosen, and it's going to be 20 times whatever the number of biscuits are that you've chosen, where that's a read. And here we go. Sean and Dean organise a quiz evening. Okay, well done. A quiz team is made up of 4 people. So team equals 4 people. Each team is charged £8 to enter. So £8 charge. And got that. Sean and Dee spend £20 on prizes, so this is the outgoings. £20 prizes. And it says £25 on food and drink. Alright, so this is the money coming in, and this is the money going out. There are X teams in the quiz. So teams equals X, so 2 teams will be 2X, etc, etc. What's that thing there? That shouldn't be there, it should be touching the screen. Okay, on average each team member spends £3 on refreshments, so that's takings, isn't it? So it's £3 per, not per team, per member. And I've got to write down an expression in X, in other words, and a little bit of a bit of maths talk with X in it, for the profit they make. Well, let's work out how much it's going to cost them first of all. Well, 20 plus 25, that's going to cost £45 straight away. Now, if I've got X number of teams and they each have to be charged £8 per group to enter, straight away, whatever my number of teams is, I've got to multiply by 8 to find out how much to charge for the entry. Now, X contains 4 people, I'm told. So therefore, if 4 people are going to spend £3 each, on average, per team, I need to work out a little expression with X's involving how much these guys are going to spend on food and drink, say. So here I go. I've got X people in one team. That each contains 4 people, and they're each going to spend £3. Now let's study that carefully. So for example, if X equals 1, there's 1 team, therefore 4 people in that team, 4X, and they're each going to spend £3. 4 3s are 12. Again, I'm just thinking it through. If for example I have 2 teams arrive, 2 times X, 2 in the X value, I've got 2 times 4, 8 people. 8 people spend £3 each, 8 3s are 24. So I think I've got that little bit right. So here I go. Let's put this all together and simplify this part. I've got 8X teams, plus I've got 12X people, and that's going to give us some income, and I've got £45 going out in terms of prizes and food and drink that had to be bought in. So what's the profit? I have got altogether 8x plus 12x, that's called 20x's, and then that's the money coming in terms of the charges and the amount they're likely to spend. And then since I've already paid £45 for food and drink and what have you and prizes, I must subtract that from the takings I will take. Therefore this is my expression in x. 20x take away 45, and if for example 5 teams come, I'd expect to make 5 lots of 20 in terms of the takings and also what they're likely to spend, and take away the £45 worth of prizes and food and drink. So that will be, say, 100 take away 45. That would give me £55 profit, wouldn't it? Not that it asks me to do that, but I'm just trying to give you a live example of where this can actually be applied, and how what you could have been asked actually in terms of a follow-up with the question. But yeah, no, getting to the 20x minus 45 is quite tricky because there's an awful lot of words to say there. And I'm probably going to stop right there, because that's enough. You've got the idea. We read a storyline, we extract the letters, we take out the numbers, make a little expression, or in the case of the the tea situation up here involving the cakes and the biscuits and what have you, then we have to make an actual formula for that. And that's all there is to the first part of formulae. So thank you.